Hello, my name is Arlencia Williams, and today I'll just be sharing a little bit of what I found from my research about black holes. I'm going to start with a quick timeline of black holes. They were first predicted back in 1916 by Albert Einstein with his theory of general relativity. In 1939, J. Robert Oppenheimer and Hartland Snyder first described the process of a massive star collapsing to form a black hole. Later on, in 1958, David Finkelstein was the first to realize the true nature of the event horizon. This is what gave us the interpretation as a region of space nothing can escape. 1964 marks the year the term black hole was coined. Scientists often spotted their first black hole in 1971 and recorded their first black hole in 2019. We all know from the course material that black holes can form when a massive star reaches the end of its life. It implodes and collapses in on itself, and we refer to this as a supernova, and it can create black holes. It has to be a pretty massive star to do this, about 300 times the mass of our sun, because anything less would turn into a very dense neutron star. But this only represents one type of black hole, when there are actually four different kinds. Stellar, which we already know, intermediate, supermassive, and miniature. Scientists have evidence leading to intermediate black holes by observing brief outbursts of X-rays where they believe the black hole is near. And based on this brightness, researchers think the minimum size of this kind of black hole can be anywhere from 500 solar masses to 20,000 solar masses. And it's important to remember when discussing black holes that though they're referred to as holes, they are anything but empty. Several stellar black holes can be likened to a star 10 times the mass our sun fit into New York City. Supermassive black holes exist, but we have yet to be able to record them directly. Astronomers believe that almost every single galaxy has supermassive black holes at its center. It can gather this information by observing its effects on nearby stars or gas. Our final and smallest black hole, miniature, is only theoretical for now. Stephen Hawking first introduced the idea of them back in 1971. A mini black hole would have the mass of about 1,000 sedans, but would be the size of an atom. And unlike other black holes, they aren't destructive in nature. Scientists believe that if they are real, they zip through the universe and possibly the Earth undetected. Black holes have been sensationalized through history via many different platforms, most common of which being science fiction novels, which paint them as infinitely massive holes that suck everything and anything close to near them into their infinite abyss. However, this perception of black holes is a sensationalized version of the evidence science has provided us. We already discussed how black holes are not really the empty spaces we think of when we hear hole, but black holes are not infinitely massive and only have a gravitational pull relative to the star that collapsed to create it. Because of this, black holes do not have an infinite gravitational power. Gravity gets stronger the closer you get to a black hole and grows weaker the farther away you move from it. It's very unlikely that black holes will ever pose a threat to us, like sucking everybody up. A popular myth is that all black holes are just black spheres in the universe that have no light around them or near them at all. They are just abysses. But this is not true. As some black holes are home to and power the most brightest objects in the universe called quasars, which appear on Earth to be very bright stars. They also may not present as black because of the red shifting that occurs when they warp time, which I had no idea of before this project. I really enjoyed doing this. I learned so much from this course and from this project, and I hope you all do the same. Bye.